So I'm gonna just write up A. You guys can check your answer for it. Critical points are derivative equals 0. I got 0 and 2. Is that a consensus? I see heads nodding. All right. And also the way I factored this was x minus 2 squared. You should be like, hey, hey, something weird happened. Okay. So increasing and decreasing. You don't need to put this one on your number line. Why not? Yeah, squared means it's going to be positive all the time. So all we need to do is for the 2x, that's going to be negative and turn positive. We're going to practice all our justifications. So how do your sentences start? F of x is or f of x has. All right, we're doing increasing and decreasing. So it's going to be f of x is increasing where? 0 to infinity, because who's your source? F prime is positive. I didn't ever write there, but is positive there. Technically, you're supposed to put there, like on that interval. And then f of x is decreasing negative infinity to 0. Good, because f prime is negative there. You guys destroyed those justifications on your quiz. You did awesome. So just do that again. All right, C, and they do this sometimes. For each critical point, how many critical points did we have? 2. We had 0 and we had 2. So you're going to have 2 sentences, all right? Write a statement with justification for whether f of x has relative maximum, minimum, or neither. So again, it's going to be f of x has, and let's do 0 first because that's the one that's actually going to have something. What's going on at 0? Negative to positive? Minimum. F of x has a relative minimum at x equals 0 because f prime changes from negative to positive there. And we're going to still write a sentence about 2, x equals 2, because it says 2. But we don't get one there because that's squared and it's going to stay, the derivative stays positive. So we're going to say f of x has neither a relative maximum or minimum at x equals 2. And there's like many ways you can say this. What's one way? How would you say it? Because f prime stays positive there, is always positive, does not change sign is usually the one I go with, but I mean like personal preference, however you want to say that. I'm going to say because f prime does not change sign there. But there's many ways you could say that. So however you wanted to word it.
That would be like it's like on that.
I was actually going to say that. I think that is the safest way to put it because if you do stays positive, but what if it was always, the derivative was always negative there, you know, so I think that's the safest way to put it. Yes, exactly. Oh my gosh, you listen to me, it's great. All right, inflection points. Now we need the second derivative. So go back to wherever you had your first derivative. That's way back up here in part A, this thing, this is where we're looking. What is the derivative of that thing? Good. Equals 0. To make the numbers smaller, those will all divide by 2. And then you can split it apart. So that will be 3x and 1x. I think 4 is going to be 2 and 2 in this case. Yeah, and they'll both be negative. So we get x equals 2/3 and x equals 2. They do both count because we don't have anything squared there. Remember, for inflection points, there has to be a change, but those will both have a change. Which we're about ready to show in part E. Make a number line for your 3x minus 2. Number line for your x minus 2. I'm not going to say this part out loud because I'm running out of voice. You're going to have to just copy it from me. So start your sentence, f of x is what? Right, concave up. Where? Negative infinity to 2/3, union. Good. Because, now who's your source this time? Yep, f double prime, your second derivative, because f double prime is positive there. And then f of x is concave down 2/3 to 2 because second derivative is negative there. Sweet. And then the last one we have is 16. That's your last free response one. You're starting to be able to do like full free response questions. I don't have to pick apart. Do you remember how I was like, you can do part C on this one and part A on that one? You're like, you've learned enough, you can do like a whole problem now. Items are being added to shelves in a store at the same time customers are purchasing them. This is, oh, go ahead and close the Chromebook. This is a rate in, rate out problem. This is guaranteed to be on the AP exam. Rate in, rate out. Items are being put on a shelf. They're also being taken off the shelf. The amount of items on the shelf is given by a twice differentiable function. They say that just to make sure you can take all the derivatives. Time is in hours from 0 to 12. Oh, what does this mean? Second derivative is negative. That means it is concave down. Write yourself a note. That is going to come up. Now, this is not a rate. Oh, I shouldn't have said that. Is this a rate? No, because it is just number of items. It is not number of items per hour. It's just the amount of items. I like to actually have a problem though. What are we selling? What do you want the items to be? Turkeys is funnier. We're going to go with turkeys. All right. Number of turkeys. Estimate the rate of change of items at time 4 hours. What do you do? Slope. Which 2 points are you going to use? Don't be too proud to write them. So it would be 15 minus 31 over 6 minus 2. Are you going to simplify that? No, because Miss Cole's answer key is not going to have it simplified. And if you do, I'm going to have to stop what I'm doing, figure out what the answer is, and then mark yours wrong because you probably messed it up. Just leave it alone. All right. Now it says show the computations. That's that. But it also wants units. Items per hour. Turkeys per hour. We'll call they're Christmas turkeys. Don't write turkeys. It was items. I just think it's funny that they called it items. Like they couldn't even be bothered to make up like a thing that it was. Right. All right. 4, 0 to 12, our interval. Is there a time? So essentially it's a yes or no. Where the function is increasing at 4 items per hour. Which theorem do you think this is? Good. Mean value theorem. Mean means average, which means slope. We want to slope 0 to 12. Do not be too proud to write out your points. It's 0, 9, 12, 57. Hey, Ms. Cole, this feels like exactly what we did in part A, but with different numbers. Yep. I've seen them do this. We just have to show that it equals 4. So, and it will. So 57 minus 9 over 12 minus 0, that's going to be 48 over 12, which is 4. We're going to have to write a sentence. All right. So since A of t is, now did they say it was differentiable? They did. Is differentiable, and I'm going to say and continuous. Then what? We showed that the slope was 4. We proved that. We mentioned the conditions. Now you restate the problem. There is a time when A of t is increasing at 4 items per hour. There is a time when A of t is, I know it's annoying, but you're just recopying it, is increasing at 4 items per hour by mean value theorem. Question? Or we can just complain about it. We can do that. That's allowed. Your feelings are valid. This is still the test, okay? Letter C, I'm gonna be able to finish this. We got like 10 more minutes. It is known that the derivative at 9 is 6. Ooh, derivative means slopes. You want to be thinking about that. Use the local linear approximation. That means write an equation of a line. What two things do you need to write an equation of a line? All right, point a slope, and they just told you the slope was 6. What's the point? 9 something. Look at your table. It's 9/18. Perfect. Put it all together. Y minus 18, good, equals 6x minus 9. Now they will not, because I've asked this, they will not mark it wrong if you use x and y. Technically, it's supposed to be a and t for time, a for amount and t for time. They won't mark that wrong though, okay? What do we want to approximate? We got to plug in something that's close to 9. We can't plug in something very far away from 9. So 8, okay. So y is approximately 6, parenthesis, 8 minus 9. And then what do you tack on at the end? Yeah, you have to add the 18 over. You do not need to figure out what that is though. Now, is this an overestimate or an underestimate? I actually think this is kind of cool. Like visually, you can see it. What did we say way back in the beginning? They told us the second derivative was negative. So we said our graph was, okay, watch me draw this. Here's a concave down graph. If you draw a tangent line, is that tangent line above or below the graph? So we're going to say overestimate because second derivative is negative. So a of t is concave down. You do not need to draw the picture. I just drew that to illustrate it for you.
This is the front.
Yeah. All right, D. The rate at which items are taken from the shelves is modeled by that thing. That's actually not too messy of a function. We've seen worse, all right? At what time is the rate a minimum? Maximums and minimums come from what? Good, and that is derivative equals 0. All right, what rule are you gonna need for this derivative? I think we're doing every rule today. Quotient. All right, actually, we already did a quotient rule. All right, denominator times derivative of the numerator, which is 50, minus the numerator. Derivative of the denominator is 2t over the denominator squared equals 0. Now you really don't need the denominator. So we're going to kind of ignore that. You still want to write it because it's part of the quotient rule. All right. Yeah, and it is, I'm sure it's a point to write the quotient rule. Okay, so write that. Let's see, if we distribute this 50, that's going to be 50t squared plus 450 minus, what would that be? 100t squared. Good. All right, and then like terms, we would have negative 50t squared plus 450 equals 0. You would subtract the 450. Negatives cancel, divide by 50. What is that, 9? Did I do that right in my head? 9. T squared equals 9. Oh, and so square root, you get 3 and negative 3. Did we have an interval though? We did. Here's our interval. 0 to 12. So just 3. You can't do the negative 3. Oh, also it's time. What on earth am I talking about? You can't have negative time. All right. Now we want an absolute minimum. Absolute means what test is this? Candidates test. Now, if you write X and Y, that's fine. I'm going to be like particular here, T and R of T. So our endpoints were 0 and 12. Our critical point was 3. For the sake of time, we're going to divide and conquer. I'll do 0. These two groups do 3. You two groups do 12. Let's see how that went. And when you plugged in 3, what'd you guys get for the numerator? Yeah, 150 over 18. Okay. And then 12, that'd be 600 because 12 times 5 would be 60. Put another 0. 12 squared is 144 plus 9 is 153. Now, we need to estimate approximately what those are so that in our minds, we can figure out what's the biggest and smallest. 150 divided by 18. Maybe try 150 divided by 20. I don't know, approximate it. About what do you think it is? Because we gotta figure out which one's bigger. 5.37. I don't honestly know.
The other one.
The other one's closer to 4. Because if you did 150 for this, so that's kind of closer to 4. You think this one's bigger than 4? Okay, let's just go with that then. We'll say this one's around 4 and then this one's bigger than 4. So which one's the biggest? Our absolute, or wait, did we need that both of them? What did they ask for? Oh, minimum. We only need the minimum. So what's the smallest one? 0. Is that what the amount to? Oh yeah, that is. Absolute minimum at t equals 0. Now I kind of feel sad about that too. I was like, hey, wait, is that the answer? I had to look back at it, and it is. Yeah, and that one's about 4, and that one's about 8. This one. If you feel like, why did we do all this work if the answer was just 0, 0 anyway? The reason why you did it is because the table is what? That is this part of it. So it's not for no reason. I don't want you to feel like, oh, we did all the work for nothing. That gets you the justify point, okay?